Welcome to my class. Introduction. Class Standard 12. Subject Higher Mathematics first paper. Chapter name Permutations and Combinations. Exercise 5A. Lecture 2. Today's lesson. Solve the problems related to permutations. Today I will try to solve in different kinds of problem that will make easy to finish this exercise. Okay, now follow the problems. Problem 1a, if n minus 1 p3 is to n plus 1 p3, this equal to 5 is to 12. Find the value of n. Solution. Given that n minus 1 p3 is to n plus 1 p3, this equal to 5 is to 12. Now this equal to, we know, n minus 1 factorial divided by n minus 1 minus 3 factorial is to n plus 1 factorial divided by n plus 1 minus 3 factorial. This equal to 5 is to 12. As here is to, also here is to, this equal to, we can write in the division form. Okay, that's mean we can write like this way. Okay, here n minus 1 minus 3, this equal to n minus 4, and here n plus 1 minus 3, this equal to n minus 2, but this equal to, we can write like this way. Clear everyone? Now as here is given division, so we can use multiplication and write this into inverse way. That's mean numerator will be denominator and denominator will be numerator. Now follow the next line. n minus 1 factorial divided by n minus 4 factorial into n minus 2. As this was denominator, here will be numerator, and this was numerator, but here will be denominator, and right side same. As here is given n minus 1 factorial and here is n minus 4 factorial, so we can write n plus 1 factorial, this equal to up to n minus 1 factorial, and n minus 2 factorial, this equal to, we can write up to n minus 4 factorial, because here is given n minus 4 factorial and also here is given n minus 1 factorial. Follow this. First part same, but this equal to, we can write n minus 2 into n minus 3 into n minus 4 factorial. We know the relation and we can write this. Clear? And similarly here n plus 1 into n minus 1 factorial. Now cut this and this, also this and this. Therefore this equal to, we can write n minus 1 into n minus 3 divided by n plus 1 into n, and right side 5 by 12. Now multiply, you will get 12 into this, and this equal to, we can write n square minus 5n plus 6, and here n square plus n into 5. Now calculate 12 n square, 12 into 5 means 60n, plus 12 into 6 means 72, here 5n square plus 5n. Now calculate 5n square, convert into left side, you will get 7n square. This convert into left side, will get 65n and 72 fixed. Now okay, 7n square minus 65n plus 72 equal to 0. Now resolve into factor, we'll get this, because 65n is equal to 56n minus 9n, and after multiplying this and this, will get the multiply of 72 and 7n square. So our calculation is correct. Now we have to take common between these two terms. Here is common 7n, and here remaining n, and here 8. Okay, and between these two terms common is minus 9, so here will be minus n, here will be minus 8. Now this equal to, we can write n minus 8 into 7 and minus 9, this is equal to 0. Therefore n is equal to 8 and 9 by 7, but n cannot be fraction because n is a natural number, and the required result n is equal to 8. This is the required answer. Clear? Now problem a number, find the number of arrangements of the letters of the word mathematics taken all at a time. Okay, and B number, in how many of them the vowels remain together. That's mean you have to take the vowel, that's mean A, E, A, I, always you have to take together. That's mean as per example, M, A, E, A, I, then we can write others letter, or we can write M others letter, then we can write A, E, A, I. That's mean vowel always together. Okay, and how many of them the vowels don't remain together? It is very easy. After finding the result of A and B and subtracting B from A, will get the answer C. That's mean this don't remain together. D number, how many arrangements begin with I? That's mean the word always start with I. Clear? And remaining will be different, no problem. A number, how many arrangements begin with T and end with T? That's mean first letter will be T and also last letter will be T, and remaining will be anyone, no problem, but within this letter. F number, in how many arrangements the two M's, two S and two T's be together? Okay, here is 2M, 1, 2 and 2A and 2T, that will be together. That's mean consider as 2M mean 1, 2A mean 1 and 2T mean 1. G number, in how many arrangements the vowels don't change their order? Don't change their order mean here A first, then E, then A, then I. That's mean always you have to keep A, E, A, I. Don't change their order. You cannot write at first E or at first I. You have to write at first A, then E, then A, then I. If you will start A here, then you can write A, then E, then A, then I. Okay, or when you will start A here, you can write at first A, then you can use another letter, no problem, but then you have to write E, and you can use another letter, but you have to then you have to write A, and you can use another letter, but you have to write I. Okay, that's mean always A first, then E, then A, then I. Clear? That is don't change their order. In how many arrangements the vowels don't change their places? That's mean A, E, A, I always fixed their places. That means second place, third, fourth, fifth place, sixth, seventh place, and ninth place. That's mean vowel always second place, fifth place, seventh place, and ninth place. Okay. In how many arrangements the vowels and consonants don't change their relative position? Don't change their relative position mean the position of the vowels second, then fifth, then seventh, then ninth. That's mean the vowels always fixed their own place. Similarly, the consonant, that's mean first place, second, third, fifth, seventh, eighth, ninth, and 10th. Sorry, 10th and 11th place. That's mean consonant always fixed their own places. That's mean first place, third, fourth, sixth, 8th, 10th, and 11th places. Okay, this is a relative position. That's mean they lie on their own positions. Now follow the solution. A number, the word mathematics consists of 11 letters, of which 2 M's, 2 S, and 2 T's, and remaining all are different. Therefore, the record number of arrangements of the letters of the word mathematics taken all at a time in 11 factorial divided by 2 factorial into 2 factorial into 2 factorial. This formula we had discussed in my previous lecture. So I think that everybody know the relation or formula. Okay, this equal to this. You can use calculator, no problem. This is a record answer. That's mean 4989600. Whereas we can arrange or the record number of permutation. Permutation and arrangement same. This is the record answer. B number, if the 4 vowels A, E, A, I are considered to be one, that's mean consider as together one letter, then the number of different letters will be 11 minus 4, as we have to subtract A, E, A, I, but this consider as 1, so we have to add here 1. This equal to 8, of which 2 M's and 2 T's. Other than this, remaining letters there contain 2 M and 2 T. Clear? Therefore, these 8 letters can be arranged in 8 factorial divided by 2 factorial into 2 factorial, because there is present 2 M and 2 T. This equal to 10,080 US. But we can arrange these 4 letters among themselves, and the arrangement will be 4 factorial divided by 2 factorial equal to 12 OS, because within these letters there are 2 S, so we have to divide here 2 factorial. This equal to 12 OS. Clear everyone? Therefore, the required number of arrangements, this equal to 10,080 into 12, and this equal to this. This is a required result. This is a required answer. Clear everyone? Now see number, the required number of arrangements in which the vowels don't remaining together. That's mean you have to subtract the answer of B from the answer of A. That's mean total number of arrangements minus the number of arrangements in which the vowels remain together. This equal to this minus this. As we have given the solution A and B, so we can easily solve C number. But if didn't given the problem or solution A and B, you have to solve at first A number, then You have to solve B. Then you will get the result C. That's mean the record number of arrangement in which the vowels don't remaining together. Okay. That means C number combination of A and B. Clear everyone? D number, determine the first places by A, because we have to start always the letter I. The rest, that's mean as I is fixed, so remaining letters will be 10. Total 11 minus 1, that's mean 10. And there is 2 M's, 2A and 2T can be arranged in 10 factorial divided by 2 factorial into 2 factorial into 2 factorial. This is equal to this. So as this is the required answer. Now in number, determine the first and the last places by 2 T's. The rest will be 11 minus 2. This is equal to 9 letters, in which there are 2 M's and 2 A's, because T is fixed, first place and last place. Clear everyone? Therefore the required number of arrangement will be 9 factorial divided by 2 factorial into 2 factorial. This is equal to 90720s. This is the required answer. Clear everyone? F number, considering 2 T's as 1, 2A as 1 and 2 M's as 1 letter, the total number of letters will be 11 minus 8. This is equal to 8, and all are different, because 2T as 1, 2A as 1, 2M as 1, and remaining others are different, so all are different. Therefore the required number of arrangement, this is equal to 8 factorial, and this is equal to 40320. This is the required answer. Z number, the files don't change their order. I have explained, just follow the solution. Since the 4 vowels A, E, A, I don't change their order, they appear as the letters of one similar category. Therefore, out of 11 letters, 4 vowels of similar kind, 2 M's of different kind, and 2 T's of another kind. As we have taken 4 vowels, so 2 M's and 2 T different and another kinds. Therefore the required number of arrangements is equal to 11 factorial divided by 4 factorial into 2 factorial into 2 factorial. This is equal to 415,800s. This is the required answer. H number, determining the places of vowels are in fixed. The rest 7 consonants, of which 2 M's, 2 T's can be arranged 7 factorial divided by 2 factorial into 2 factorial equal to 1260s. Therefore the required number of arrangements, this equal to this. This is the answer. I number, for this case the 4 vowels are arranged among themselves at the fixed 4 places. That means 2nd, 5th, 7th and 9th places in 4 factorial divided by 2 factorial, because there is 2A, so we have to divide by 2 factorial. This is equal to 12s, and the 7 consonants are arranged among themselves at the fixed 7 places. That means 1st places, 3rd places, 4th, 6th, 8th, 10th and 11th places in 7 factorial divided by 2 factorial into 2 factorial. This is equal to 1260. Therefore the required number of arrangements is equal to 12 into 1260. This is equal to 15120s. This is the required answer. Clear everyone? Problem 8a. Find the number of ways in which the letters of the word permutation may be arranged without changing their position of any vowel. Rearranged means permutation is an arranging word. So other than permutation, we have to find another word. Okay. So at first we have to find the arrangement. Now for the solution. The word permutation consists of 11 letters, of which 5 vowels. Determining the places of vowels are in fixed. The rest letters will be 11 minus 5. This is equal to 6 consonants, of which 2 t's can be arranged in since 6 factorial divided by 2 factorial. This equal to 720 by 2. This equal to 360 OS. Total arrangement. But permutation is a arranging word. So the rearranged, the word permutation can be rearranged in 360 minus 1. This equal to 359 OS. Follow this rearranged. Rearranged means you have to subtract 1. Okay, because this is a arranged word. Rearranged means other than permutation. Clear? Okay. How many odd numbers of 5 significant digits can be formed with the digit 65230 using each digit only once in a number? Okay. As solution, since all the numbers are odd, each of them must end with 5 or 3. Okay. The unit place can be filled up by 5 or 3 in 2 ways. That's mean right number. That's mean unit place. Then 10th place, then 100, then 1000, then 10,000. Unit place mean right number will can be filled up by 5 or 3 in 2 ways, and the other 4 places can be filled up by rest of 4 digit in 4 factorial. This is equal to 24 OS. The odd numbers can be formed in 2 into 24. This is equal to 48 OS. But the odd numbers begin with 0 can be formed in 2 into 3 factorial. This is equal to 12 OS, which are not actual numbers of 5 significant digits. Therefore, the required numbers 48 minus 12, this is equal to 36 OS. This is the required answer. Clear, everyone? Now assessment. Find the number of OS in which 14 SSC candidates and the 10 HSC candidates can be arranged in a line so that no 2 HSC candidates may occupy consecutive positions. And problem 2. There are 3 candidates for a professorship and one is to be selected by the votes of 5 men. In how many ways can the votes be given? Now homework. Solve the problems related to the lecture and submit the copy in the group. Date of submission 25/7/2020, time 9 p.m. I think that everybody now can easily solve the exercise 5a, and if you face problem you can share with me, no problem, I will help. So today up to this. Thank you to all everybody.